So you had a problem on the test, and you've seen this in the homework, systems of equations. Right? And the whole idea of system of equations is if I just tell you this, say x plus y equals 7. That's not enough information to pinpoint what both values are. I have two things I don't know and only one piece of information. So it is a lot like some really hyper lame CSI where I'm trying to figure out an equation and stuff. But when I'm trying to solve a murder, what do I keep looking for? Evidence, clues, information. I got a lot of shit I don't know. Why was this guy killed? How was he killed? When was he killed? Who would have killed him? All this shit I don't know. I'm trying to find clues. I got the guy come in. He's this temperature now. That means he's been dead for this long. Okay, we got an approximate time of death. Okay, well, who was around? I'm trying to get information because there's a lot of shit I don't know. So if I only had one thing I didn't know, like x, I just need one equation, and then I can solve it. One thing I don't know, one piece of information, beautiful. Two things I don't know, I need two pieces of information, right? So what if I also told you that the difference between them is 3? Can you just reason this out? I want two numbers that add to be 7, and they're 3 apart from each other. Can you just think about that for a second and get the answer? Without even using any algebra. 5 and 2. I love it. Right? 5 and 2 make 7. And 5 minus 2 is 3. I like it. 4 and 3 doesn't work, right? Because 4 minus 3 is 1. So if my other piece of information would have been 1 here, then 4 and 3 would have went to jail for killing something. I don't know. Okay, maybe. All right. Everybody with me? So, of course, this is old news. What methods can I use to solve this? I can use elimination. I love it. It's my favorite. Good old elimination. It's very, very direct. I'm going to kill something, right? It's very direct. Substitution is the other way. That's more like some weird spy action going on. I'm going to replace this guy. Yeah, that's weird, right? Or some sci-fi invasion of the body snatcher shit. This is just very in your face. Die. Why? Why am I going to kill Y? Yeah, it's already different signs. I love it. So I'm going to add these together. Now, really good question right now is, why the shit am I allowed to add equations together? What the hell? I thought if you do something to one side, you have to do the same thing to the other side, Jeff. And you're doing some weird ass shit to, what the hell? So what am I adding? If I add these together, what am I adding to 7? 3. So I'm adding 3 to this side, right? But 3 is x minus y. Do you guys see that? 3 is x minus y. So if I add 3 to this side and I add x minus y to this side, I am doing the same thing to both sides. That is why I'm allowed to add equations. Let me stop there for a second. Some of you guys are like, I didn't even think about that question. Somewhere in your brain, you're like, whatever this shit is, I'm just going to do it. But now, so now if I do add them together, x and x, 2x, the y's go away. 7 and 3, 10. X is 5. And you know not to stop there because there's two things I need to know. If x is 5, y obviously has to be 2. Y is 2. So then the answer is actually going to be, you can put it as a point. Because really, graphically, what is this related to? Graphically, what is this related to? If I graph this, what's it going to look like? A line. If I graph this, what's it going to look like? Another line. This is the point where they meet. I love it. All right. In fact, why don't you take a minute and graph this? Go ahead. Be a nice little review. Graph both of those equations on the same little graph. me see if I graph this one, I solve it for y, I get that sucker, right? Y-intercept is 7. And from there, I want to go
Down one to the right one.
yeah, down 1 over 1. I like it. Down 1 over 1. 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 Okay. Whee! Make the points big. Yay. Bam. And then this guy, if I solve for y, add y, subtract 3, get x minus 3. So then the y-intercept is -3, and I go up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1, up 1 over, hey, make the points big, a crappy scale. And there and sure enough, they meet at 5, 2. Okay, I like it. So anytime you solve a system of equations with 2 variables, the answer you get is where the lines would meet if you graph them. Do lines always have to meet? No. They could be like that. Then what would the answer be? Well, if the answer is where they meet, and they never meet, there's no answer. There's no solution. I love it. Or they could be one line on top of the other line. In which case, where do they meet? Every point on the... So then what's the answer? Every point on that line is the answer. Holy shit. That's like me saying, okay, I'm twice as old as you are, and then I say, let me give you another piece of information, because you don't know how old either one of us is. You are half as old as me. Did I just give you 2 pieces of information? Did I? Yes. If I'm twice as old as she is, and then I go, oh, she's half as old as I am, didn't I just say the same damn thing? And you're like, that didn't help me out. Yes?
Why did it become -3 when you graphed it?
Oh, if you subtract x and then divide by a -1, it would become, right? So.
I just like steps.
Subtract x.
Okay.
Me too, but I figured that was not too bad. -1, -1, -1. Right?
Oh,
Yeah.
got it. Okay.
Cool. What I do, real quick, if the thing I'm solving for is negative, I add it. And then whatever's over there, I just plop it over there. So really those switch. You get x, y equals x minus 3. Okay, cool. I like it. So you got elimination, you got substitution, and you actually have the graphing method, but the graphing method is not the best because the answer might be wonky, and I was barely able to get the right answer for if it was whole numbers because of my crappy scale. What if the answer was 5.29, comma 3.777771, and I'm never going to get that off a graph I made. I'm nowhere near that good resolution-wise. Okay. All right, so what happens then if I have one more variable? So let's find out. It's almost the same thing. It's just you should expect it to be a little bit more work. And well, first off, what the hell does one more variable mean graphically, right? So, what is this? X equals 1 is just a point, right? X plus y equals 1 is a line, right? Could be y equals negative x plus 1, blah, 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 be this line. Whee! Point, a line, 1 dimension, 2 dimensions, 2 variables. So if I add one more variable in, what are we talking about now? What's the next step up from a line? The plane. If you put a bunch of points together, an infinite number of points, you can make a line. If you put an infinite number of lines together, you make a plane. And why do I do this? Because that wall is a plane. It's got an equation. It's got an equation to it, believe it or not. Right? And so if I have 3 things I don't know, how many more pieces of information do I need?
3.
Well, I need 3 total. I like it. So I need somebody have to tell me 2x minus y plus 4z equals 7 and negative 3x plus 2y plus z equals 2. So this, let's pretend for a minute. This is that plane. Right? I like the visuals. This is this plane. The second one is the ceiling plane. Right? So I got the top one is this plane. The middle one is the ceiling. And the last one is this plane. This wall here. You with me? All right. What sucks a little bit about my example is it's got a little bit of a wonkiness in this corner here, but oh well. So where do those three planes meet? At the corner point, right? You guys with me? Mm-hmm. Now, two lines don't have to meet. Three planes don't have to all agree on a point. So there could be some of these that just comes out to no solution. How are you going to tell it's no solution? You'll get something like 0 equals 2. Something obvious. Right? No solution. I love it. Okay. So how the shit, well, let's see. How in all of hell are we going to solve this? So the way I like to do the very first problem is to show you how I make a problem. And yes, sorry.
Why would they not meet?
So are you cool with me saying this is a plane here, right? So that's cool? Pretend like it goes forever in all the directions. That's a plane, right? So I could have two planes meet, and then the third plane could come in and intersect it at, and there could be one point that they all agree with, just like we did with the corner point, right? But very easily I could have two planes that never meet, right? Yeah. I could have three planes that meet at a line, in which case there's no single answer, there's no point. Right? I could have three planes, let me see you guys. I could have this plane hit this way, and this plane come in and hit there, and they meet at that line, at that little spine of it. And back in the day, there was something called a Rolodex, right? And there was, like the spine of it was where all these planes met, right? So every index card that you had in a Rolodex was like a plane. And where'd they all meet? At the spine. So was there a single point answer? No, that whole spine was the answer. There's an infinite number of frickin' answers. So I could have three planes, 1, 2, 3, that behave nicely, and they all intersect at a single point, right? That's what we're always kind of looking for. But what does it mean if I don't get an answer? It means either the two of them were parallel to each other, or they just didn't all come together at one point, right?
So then the three equations wouldn't have to work out.
Exactly. Same way with systems of equations don't have to work out. I can get 5 equals 7, and I'm like, well, that's shit. Because the two lines were parallel. They didn't meet somewhere, right? So there's a lot more ways for planes to not agree on a single point. All I need is this one of them to be a little bit off, and then the whole thing goes to shit. Okay, maybe. Which means that the one I just had up here, the reason I erased it is I put money on it not having an answer. Okay, so here's the way I make a problem that has an answer. I start with the answer. Now, what I'm about to do is just show you how I make a problem, just so we can get used to the process, right? So let's see. Give me a number, positive or negative. Make it a whole number. 3? Give me a negative number. -2. And then whatever you want there. 5. Okay. All right. Now, so we're all the teachers right now. We are teaching students this process of solving 3 variable equation systems, right? So we start with what we want the answer to be, so that we know there's an answer. It's a pretty good idea. In the real world, the 3 equations would come from observations we make in the world. We created an equation, so if we're talking about weather, we create an equation for the influence of humidity on this and that, and another equation, then I see where they meet. Or even better, I could have an equation that represents some missile's trajectory, and an equation that represents my interceptor missile trajectory, and I really, really would want those to meet at the same time, so that we don't, get hit by the stupid missile. Are you guys a little bit with me? Yes. Okay. So that's an even better example of wanting to solve systems of equations. So I know computers do it for us, but they're made by humans. So the humans probably somewhere have to know how the hell to do it, so they can program it correctly. So watch this. I'm going to start off the first equation. Let's just do this: x plus y plus z. So this is x, y, z. Is that cool? So we're not going to do a lot of 3-dimensional shit. I just don't want you to get all freaked out. You're not going to have to graph 3-dimensionally, any of that. But I want you to realize that for section 9.1, and in fact chapter 9, we're in the 3rd dimension. Right? You're there every day, but now we're doing math in the 3rd dimension. Not only are we 3, so 3 negative 2. I don't put a point here because then I have to go 5. Right? There's another axis coming out of the board. Is that cool? Because 2D is good for finding a point on a plane. But what if I want to find a point in this room? Well, I better be able to get the freak off the board to find that point. Are you guys with me? So that Z piece is how far above or into, on the other side of it, that I have to go. Okay. Are we going to do a lot of that stuff with that directly? No. But I want you to remember that's where we are right now. So what number has to go here so that I know that's going to be the answer? 6. Where'd that come from? Yeah. I want x to be 3. I want y to be negative 2. I want z to be 5. So 3 minus 2 plus 5 is 6. So far I know the answer is going to be that. Now, how many answers does this equation have?
1.
How many answers does this equation have? What about 2, 2, 2? What about 1, 0, 5? What about 20, negative 14, 0? There's an infinite number. In fact, there's like an infinite. Sorry. But let's just say there's an infinite number, right? Are you guys still with me? You know there's an infinite number of answers to this equation, right? And that's why we have to graph the answers out, so I don't have to list them. Listing the answers would take the rest of everybody's life and everybody's kids' lives and so forth. Graphing the answer, I'm done. Go find which one you want. Right? There's an infinite number of answers. The line goes through all of them. Leave me alone. Right? So here, holy shit, there's going to be, this is what I meant. I added one more thing, so there's like an infinite number. Holy shit. Okay, so let's make another equation that has that as an answer. So what if I did 2x minus y plus 4z? Let's just take a minute and try to figure out what number goes on the other side. You can do it. Because I know what I want x, y, and z to be. This is what you're not going to be given, obviously, because this is what you're trying to figure out. But I'm trying to create a problem that has that as the answer. So twice 3, right? I want x to be 3. 6 minus negative 2. 6 plus 2 is 8. Plus 20. 28. This is the thing you guys are normally not shown as students. You know we're not shown this. Right? Have you guys ever seen something like this? I mean, this is, if I want to make a series of equations that will have a nice answer, I better start with the answer to make sure it comes out nice. If I just randomly make shit up, either there won't be an answer, or the answer will be 1.7222934. Oh, God. All right, so what about the last guy? Let's say negative x plus 5y plus 2z. Yes, let's see. Negative 3 minus 10, right? Negative 13 plus 10, negative 3. 11. Okay. Let me stop there for a second. Now, what I just did, would you ever be asked to do that? No. Because this is actually the behind the scenes. The how do we make a problem that has a nice answer. Okay. So, if only the stupid z's weren't there, I would know what the hell to do. Like here, I could just add these together if those stupid z's weren't there. Or if the stupid x's weren't there, I could do the same thing, right? So you should expect this to be a little bit longer process. The really nice thing is the process pretty much always is the same. You want to pick a letter and kill it twice. Let's see why. Right? It doesn't really matter, but let's just kill the x's. Now notice, the y's would be a good choice also. Right? Now why am I saying that? What's really nice about the x's, for example? What's one way I can kill the x's? Add the first and third equations, right? So if I do 1, oh crap, my poor little, plus 3. Equation 1 plus equation 3. Now I know 1 plus 3 is 4, but I'm going to call it equation 4 because it's the next, I've got 3 equations already. So no matter what the hell I do, I'm going to make equation 4 here. So what do I get when I add 1 and 3? Well, the x's cancel. 6y plus 3z equals 3. And real quick, just notice that, look out for this, what I'm about to say right now, look out for this. Can't I reduce that equation? Do you see what I mean? It's almost like reducing a fraction, that's why I call it that. So what can I do to that equation? Make the number smaller, I can divide everything by 3. So I get 2y plus z equals 1. So that's one new equation. This is better than any of these because it only has 2 things I don't know instead of 3. So it's sort of like piecing together information, and I'm like, okay, now we know when he died, when he was killed, and we still got all this other shit, but at least we got one unknown gone, right? Now, I don't know the value of it, so it's not exactly like that, but this is a better equation as long as I don't lose any of these guys, because it has one less unknown in it. Now, do you understand? If I only had one more equation that has y and z in it, I know what to do with those. So why don't we go back and make one more equation that only has y and z? So I want to kill x again. So what 2 equations instead of 1 and 3? It's got to be 1 and 2 or 2 and 3. It can't be 1 and 3 again. Get the same damn thing. How else can I kill x? Yeah, 2 and 3 is good. No, 1 and 2 would work, but why is 2 and 3 a little better? They're already opposite signs. Remember, and if you have to multiply by negative, you can make a negative mistake real easy, and that sucks so bad. Okay, I like it. You guys are doing pretty well with this. It's always so exciting. I know. Yes, ma'am.
This may be a stupid question, but if you're adding lines 1 and 3 to make line 4, why do you still have them up there?
Because if I get rid of them entirely, I'm losing. These are still valid pieces of information. What I'm gonna do is I'm gonna get y and z, one more equation y and z. I'm gonna kill like the y or the z and figure out what the other variable is. All right, so if I knew that y was 1, couldn't I figure out what z is? Yes. But then I need to figure out what x is. I better keep to these because they have x's in them. I can then pick one of them to figure out what x is. So these are true. These are true statements about this problem. Those are true. We made one more thing that's true. It's a slightly better thing for us because it's got less shit in there that I don't know. But these are still there. These are still true. So let's see now. What are we talking about? We're going to use 2 and 3. I'm going to take 2 plus, I'm not going to add these together the way they are. What am I going to do? 2 plus twice 3. All right, so let me write this out. So here's 2x minus y plus 4z equals 28. Here's twice 3. Twice 3 would be negative 2x plus 10y plus 4z equals negative 6. Is that cool?
Why are we multiplying by 2?
Because then what happens with the x's?
Oh.
Yeah, so remember, we pick a letter. Whatever letter is easiest or whichever letter you hate the most. The z looks shifty or whatever. So here we said, screw that x. Let's kill him twice. All right, poor little x dude. So we killed him once already. Now we're going to kill him again. So those go away, of course. So now it's going to be equation number 5.
9y.
Yeah, 9y plus 8z equals 22. Good Lord. So there's my second more useful equation. And now these two, I can use these two to kill a letter. And then I know the value of the last letter. I know the value of it. So I'm using all my pieces of information with each other and connecting them together. Right? So you knew the guy and he owed you $10, but you lived right next door to him, but you weren't home last night. I'm trying to put all this stuff together, all the information together. So that's what this whole, I'm mixing the information together to get better pieces of information. So now, by the way, I've got a little handout that's got all these steps on it for different problems, so you can look at it to keep straight. What do I got? I got the fourth equation was 2y plus z equals 1. The fifth equation is 9y plus 8z equals 22. How can I kill something easiest here?
4 by negative 8.
Yeah, multiply this one by negative 8. I love it. Cool. I could multiply this by 9 and this by negative 2. Oh my God. So if one of the variables doesn't have a 1 coefficient, it's sort of related to LCD idea then. You guys see that? LCD would be 18. But here I could just multiply him by that number negative and kill it. Yes?
Could you still substitute by z equals?
Oh yeah, totally. You could solve for z and substitute it. Right? Totally. But here, I want us to get a little more used to just pure elimination because that's going to kind of rule the day, especially in the next section when we get into matrices. It's going to be all about elimination. So if I multiply this by negative 8, what do I get?
Negative 16y.
Negative 16y
Minus 8z.
minus 8z is negative 8. The most common mistake is to forget the other poor side. And now you combine these guys, and what do you get here? Yeah, negative 7y equals 14. Divide by negative 7, we get y is negative 2. Right? Which is what it was.
How did we eliminate the 8?
Well, what's 8z minus 8z?
I know, but before it was just 2z. Oh, I must have written it wrong. What plus 8 is z?
Yeah, so I got 2y plus z equals 1.
Right.
9y plus 8z equals
How did
22.
that become 8z? So y plus 8z.
It didn't. It never did. I multiplied this by negative 8. So then it becomes negative 16y minus 8z equals negative 8.
Multiplied equation 4 by negative 8.
Yeah, 4 times negative 8 is here.
Okay, but not exponents.
No, that's minus.
Okay.
Oh, I'm sorry. Yeah. There's no real, I mean, I have to go back to x for times for this little note. Just telling myself what the hell I did. One thing you'll notice is if you are somebody who kind of is all over the place when you do a problem, this is going to be your nemesis. You need bookkeeping. You need to number your freaking things. So you make sure you know where things came from. And it also makes it easier for me to grade. Right? Because one big thing, there's a lot of places you can make a stupid little mistake. Some of you guys saw that immediately, like, oh my God. If you rewrite one thing wrong and this is a minus, or you rewrite a 3 as a 2, the whole thing goes to shit. So how do I grade these things to be fair? I see if do you understand the process? Do you know what you're trying to do? That's what I graded based on, right? So I know y is negative 2. What can I get right now immediately else from that? I've figured out a piece of information. Now everything's going to fall. I sometimes call this dominoes. Not because it's pizza, but because I can fall back, right? I know this, I fall back here. I can figure out what z is now, right? And once I know y and z, I can fall back here, pick one of these and figure out what x is. I like it. So how do I figure out what z is? Well, I would use this equation because it's already almost solved for z anyway. Y is negative 2, so this will be twice negative 2 plus z equals 1. That's negative 4, add 4z is 5. Thank God. And now I know z is 5. I know y is negative 2. I can plug it back in here to figure out what x is. So the x minus 2 plus 5 equals 6. This is 3. Subtract 3. I get x equals 3. Okay. Okay, maybe. So there's two levels to this. Either you'll hate this because you don't understand it, or you'll hate it because it seems like busy work. I don't care. You just got to be able to do it. All right. So here, let me give you one. Let me give you this handout. Oh yeah, I was using these as planes. One side is section 9.1, what we just did. So I'm going to give you an example to work. The other side is matrices, so you might not want to look at that side yet. All right.
What are some real-world applications of this?
So like I said, you could have an equation that relates to the trajectory of something, and the equation that relates to the trajectory of something else. Will they always be linear? Do you see what I mean by these are linear? Because all the variables have a first power. No, normally trajectories are going to be curved. So maybe something in here is squared, something in here is cubed, but the basic idea of solving it is the same. Where did I leave off? Here. Now, just to go off a little bit on math philosophy, I don't mind that question. That's a really good question to ask. But there's a ton of math that people just did back in the day just to see what it would look like, to see where it would lead. And they got all this weird shit that had no meaning before. But we constantly nowadays, in the last 20 years especially, are like, this thing this guy did back in 1807, it exactly explains this, which we need to figure out so that we can see if there's going to be radiation from this neutron star thing coming our way. He figured out this equation that does that. He was just playing around with shit. So there's a whole level of math that's just playing around with shit because who knows when it's going to become, useful, right? Okay, so let me give you guys one to try. I'll take it right out of the book, I think, so I'm not wasting our time trying to come up with one that works. Here we go. Cool. And by the way, some of you guys, one of your main mistakes in the homework is writing the problem down wrong. You'll write part of number 7, and then you'll put part of number 8 in there, and then you're like, well, this is not possible. I'm like, well, yeah, of course not. Here, holy shit, right? You're going to want to triple check what you've written down against what the book says before you get started. Because if you write something, if you put a minus, it's supposed to be a plus, you're going to waste a lot of time trying to solve that, right? Please check it after you write it down, just like I'm doing right now.